Hello, today we will talk about scientific research methodology. Probably it's not so bright topic in our course, but it's very important. General scientific methods used for empirical and theoretical research and include some category like abstraction, analysis, synthesis, analogy, induction, deduction, abduction, modeling, historical and logical methods, and graph methods like that. And we shortly talk about some from this method and continue with some evaluation of quality, scientific research, and some basic information from this topic. Abstraction is method from in basis of this method it's imaginary distraction from unimportant properties, signs, connection, relation, all the studied objects and phenomena, and simultaneous allocation and fixation on more significant sites, more interesting for researcher, and significant properties of object. Uh, it's this distinction made between process and abstraction, and the result of abstraction, which is called abstraction. It's not easy to understand, but it's should take it. Uh, a very important method is analysis and synthesis. Analysis is splitting uh, something whole into constituent elements, isolation of features of subject and studying separately. It's as parts of this main structure, main holistic structure. Rigorous analysis is very important for construction of research work. It's like dissertation, monographs, or research article. Um, it's this methods come from logic philosophy, and it's very effective method of knowledge. It's and, we can use without laboratory operation only by facts. In order for analysis, it's the thing to become possible. It must be fixed in our continuous as well prerequisite from analysis and is holistic systematic perception of this object. Um, Based on this uh, direct or empirical analysis synthesis, it's we move to more familiar understand this object. At the same time, separation of this part of object later and next continuous detection of properties, object simplification, measurement. It's help us fiction on important data of this object. It's we have some approaches for in these methods. It's like reverse of elementary theoretical analysis or more deep structural and genetic analysis and synthesis. We can understand it like different level of investigation of object. Um, Another method is induction and deduction. Um, uh, this inductive inductive method move from simple observation to generalization to more big element in constructing theory. Deductive opposite opposite method. It's move from some general information, general theory to split in more small parts and move to some simple conclusions, simple experiments, simple fact information. Um, this method move in opposite direction, and this probably you remember this Sherlock Holmes detective story by Arthur Conan Doyle when this detective used deductive method from some general information or some facts, and this helps in this activity. Another method is modeling. Modeling is create some copy of original object and studying this copy in mind in this some continuum or program or this imagine. Yeah, this model, this copy replace original object in this object can be this some studying, discovering, etc. This is simplified simplified explanation of modeling. More this next method experiment is we can it's more easy understand it by this experiment. It's something we can touch in laboratory. It's one type of experiment. Experiments are divided on natural, artificial, laboratory, and industrial. An example, natural experiment conducted in some natural environment of usually it's social in social sciences, some study in social group, something or some nature, probably it's like zoology. Artificial experiment is this we isolated this study from external influence, and this it's like guaranteed to more precise evaluation, quantitative and qualitative indicators. It's spherical, some sphere. Uh, Laboratory experiments conducted using typical devices, stands, and equipment, lab equipment. It's we later we will talk about it. Um, Another, it's I take this uh, old Soviet old Soviet handbook is production experiment in study process in real condition of like in industry and taking in account influence various random factors of the production environment because it's in theoretically often it's theoretically all work fine, but if we start produce or doing something, it's always going wrong. And this production experiment helps us justify verify these environment factors which can influence on process. We move to some evaluation. It's in evaluation of the quality of scientific research is question of meteorology, meteorological measurement. It's it's by some technical tools we can find the physical quantity of this process. Also, it's we can understand this like cognitive process comparing value with standard. So in comparison, Measurement divided into static and dynamic. It's easy to understand. Uh, in also divided some classes of measurements. It's from highest is especially accurate. It's highest possible accuracy of this measurement. It's like some atomic uh, atomic method in this evaluation of time. An example of some length of waves for some longevity, etc. It's some from system international measurements. Next is high precision measurements. It's in we use some devices with specific values of error. It's we know error of this device. It's usually it's very low. Uh, this low error and microns or angstroms, etc. An example is some physical physical uh, uh, values. And the lowest is technical measurement. It's the errors in these measurements determined by features of measurement tools. It depends on these tools. It's like in buildings, etc. um, it's very difficult question of evaluation efficiency of scientific research. It's usually this effect evaluated by economic effects. It's some if it's something useful, it's uh, this lead to money, income growth, or cost reduction on this different process in industry, in scientific research, in social society. Socioeconomic effects, it's evaluated by increase of productivity, improvement in working condition, it's some ecology evaluation, it's protection of nature from human activity, industrial. And another question, it last lecture we talk about different category of science, fundamental, applied science. In fundamental science, which not directly connected with some practical activity, it's scientific novelty. It's another indicator of of scientific research. Some it's we can define it's like scientific result is which it was previously absent in science, and it's very important in the PhD defense and some if you get some scientific degree, etc. It's defined these levels of novelty. It's first concretization, addition, and transformation. Okay, it's more detailed about levels of scientific novelty. Concretization is if you know something, but it's we make clarification and provisions of individual aspects of the work and detail this work. It's not so high level of novelty. Next is additions. When you add something useful information uh, to approaches expand these approaches, introduce some new accents in understanding of the of problem. But main essence of this approach not change. You improve something. And highest level of scientific novelty is transformation. It's a result, obtained result of scientific research. It's fundamentally changed of understanding problem or previously existing knowledge. It's it's for theoretical theoretical category of science. But technical science characterized very simply on two level. It's I trying to before lecture I trying to demonstrate a website and on this my rational proposal for this device of concepts. It's technical science have two levels. It's invention and rational proposal. And invention, it's something new with significant difference from previous solution, technical solution of the problem. It's uh, it's a new device or new approach. It's something not exist before. Rational proposal is improvement of existing device or existing approach, existing document, etc. It depends of type of science, category of science, etc. Okay, we back to economic efficiency. It's, for this evaluation exist many mathematic huge mathematic operate, and it depends of cost we invest in scientific research and uh, evaluate some income or economical growth. But it's simply its economic effect is annual summing of life of objectified labor or expressed. This economic effect always expressed in monetary equivalent. It's not easy to evaluate, but it's a lot of people work for this problem and exist very good, very big mathematical apparatus for evaluation. It's economists working for that. And final form of realization, it's create something good which can take from any form of benefit society. It's probably not obvious benefit, but it's improve society in some different aspects. Um, Now we continue. Next chapter is some quality of research. In quality of research, it's depends of this uh, system of quality management, some quality of device and organization work in scientific research and control of this uh, of this research in some way. It's the simplest way. It's um, safety technique in lab. um, okay, it's mechanisms of management and continuous improvement of main process to achieve a high level of counting this cost. Um, in uh, this graph, it's we can see some uh, obvious outcomes of this improve in creating this quality management system. This leads to some obvious good for and for research societies. Some uh, in, improve decisions, increase reputation, and customer satisfaction and success of projects. All we talk about something very good, very good outcomes and making some implement some best practice. It's good looks on paper on presentation, but usually in when nowadays when university transform in corporation, big university transform in transnational corporation, and these corporative rules, this diffuse into this academic. Uh, it's create some new universities. Probably not all people very appreciate because it's in when this quality management system uh, implementing in universities additional working units, additional people wait salary for controlling you. But theoretically it's work fine. But production experiment, I refer to previous slides. It's demonstrate something another. Okay, we continue. This quality management system is important for monitor, control, and fix indicators and constant improvement. Proactive plan it's helps us become better, but practically it's leads to rising more documentation in lab. It's logbooks and some journals of disinfection, temperatures, and additional paper workload. And presents instruction in each corner of lab because it's each device use it's need to supply support some instruction for fix some problem if we have a problem. Um, let's, uh, we move to more practically working lab is some general rules and we work with equipment and this equipment always should be cleaned. It must be in broken order and without technical issues. If we have some problem in lab on this in process of research, we should inform some responsible persons. It's we control level of usage of equipment and keep technical documentation and before usage we make some courses for this for training people who will work. Uh, practical next practical part is I focused on some very widespread equipment in very sensitive equipment in lab. And we will talk about this balance, automatic pipette, centrifuge, and pH meters. Um, let's start with balance. In our lab, its balance was first valuable device when I come to this department. It's by my I ask about this new balance. It's more precise scale. It was first step in building lab. um, Usually balance, electronic balance, it's fragile and sensitive equipment, and we should avoid turbulence and direct light and temperature and fluctuation. It's very important. It's if you trying to work with milligrams something. Uh, this balance always put on flat surface. Usually it's balance have some balloon into for centering. Uh, it's we protect balance. It's usually some have metallic parts from acids. It's some aggressive liquids, etc. Um, it's in lab we should keep some constant temperature, very convenient for lab workers. Um, Not place hot objects, brush and remove and clean this device, and always use this some reload in it keeps from this device from different uh, uh, influence, which can damage our process of evaluation. Is some measurements. Okay, okay. In the end of measurement, we is reset scale to zero. Next, widespread devices, automatic micropipettes. In our lab, since we work with immunohistochemistry, histochemistry, we use small amount of chemicals, and it is very important because precise into these very small amounts of antibodies and some serum. It's critical for right diagnosis, etc. Uh, Always when we work with micropuppets, we check what the scale, not use acids for and another aggressive liquids into these micropipettes. And this, in case if something going wrong, we inform these responsible people. Um, it's also very important keep some temperature regime, not very cold and very hot liquids, not used for this device. And um, this in this case, we on this picture we demonstrate how it's right position of this pipetting. Um, And always, if we use automatic micropipettes, it's press button this very slowly. Um, it uh, some we have more simple volumetric pipettes. It's with use for more aggressive or viscose dense material. And, it's these pipettes keeps more valuable automatic micropipettes. It's demonstrate it's human have more this diapason for this in measurements because human is uh, depends on many factors. It's examples. Next, a very widespread devices in labs since biolabs is centrifuge. It's, this device is quite dangerous because it's most of centrifuges have very high speed of rotation, and this we should be aware. Uh, Before centrifugation, we should check always this is some number of spins and time and power of centrifugation. And this check dishes, Eppendorf tubes, it's device. This material suitable for centrifuges or no. Check of some units of measurements, etc. This centrifuge should be clean and dry without mechanical damages. And always we check about this lid close or no, because it can lead to some big problem. Also, check and correlate with material which should make centrifugation. It's some result of um, damage of this safety technique, and it's lead to destroying centrifuge because it's several thousands rotation in minute. It's very dangerous. It can be damage lab personnel, etc. This lead to very significant destroying into lab. Okay, next important device is pH meter. This pH meter use electric potential for measurement of uh, hydrogenium ions into environment. It's for this reason pH meter called potentiometric pH meter because it's electric potential related to acidity, alkalinity of environment. In uh, this device based on electrode. It's in some external electrode and silver electrode, which measurement potential into liquid, and this difference between this potential lead to uh, reveals us this uh, this acidity or alkalinity is level of pH. And when we use pH meter, we should this use fresh liquids, fresh uh, control pH example for comparison with this liquid which we trying to make measurement. Uh, Always we should clean these probes, electrodes, and wipe it to dry. And keeps electrodes in special solution. It usually is 3 molar uh, kalium salt, kalium iodide. Um, Before usage, we should calibrate and check this patient work properly. These examples with evident pH 479, it's always should present into set for pH meter, and we check on these uh, on these points for more precise measurement. And in case when we calibrate pH meter, we switch off and wait some time for warming up all these electrodes. And after using, we clean these electrodes. First, the buffer should be neutral. The second, it's we move to acidity pH 4 or alkalinity to pH 9. Uh, this all buffers should be the same temperature because it leads to change pH. Always we should calibrate before we use these pH meters. Uh, um, it's one practical class I should demonstrate by camera. It's in in my lab. I also have this pH meter, and probably next or in several practical class I should demonstrate histolab and microscopy lab is some device. Also, we have this pH meter. Okay, for last chapter, some conclusions is equipment for general use. It's maybe always clean, wash it in we left all devices in working order. If we notify it is some malfunction, we should informate some responsible person and not use if something break. Technical documentation should be located close to devices, and people without training not be users of device, sensitive device. That's it. So, okay, thank you. Today we talk about something uh, this quality management and evaluation of scientific research. Okay, thank you.